Good morning, everybody, for joining us for AWSITC webinar session powered by Vidyadaan. So as Vidyadaan have been bringing a lot of webinars, workshops in association with AWSITCs, today also we have a special one for you. Like MESC platform on Vidyadaan, we always try to provide information and knowledge to all the people aspiring for career on M&E sector and also for the professionals. Like I've just mentioned, webinars, workshops, chat shows with eminent personalities, and we have been trying to encourage and motivate people to learn or polish their skills that may further be used post the lockdown and of course throughout their life in their career. Today we have a very interesting and fun-packed webinar with two highly professional people from digital gaming and production industry. So who have worked with Epic Games, Unreal Engine and Last Pixel. So for today's session of Media and Entertainment Skills Council, AWSITC and powered by Vidyadaan, we will be there with Mr. Hanif Mohammed. Mr. Hanif Mohammed is a founder and CEO of AID, that is Asian Institute of Design. Mr. Hanif brings in more than 20 years of expertise in executive management in education sector. He was one of the founding members of Middle East College, a leading higher education institution in Sultanate of Oman, serving students from the region and around the world. He is also on board of various companies such as EduEast Services Private Limited, Evolution Culinary Private Limited, Singularis Biztech Private Limited, and serves as a regional director India and Southeast Asia as a Smart Knowledge Alliance. So, I really want to tell you about our special speakers also, but I would love to give this opportunity to Mr. Mohammed to let us know about our speakers. Mr. Mohammed, I welcome you here on the Vidyadaan platform, and we would really like to hear it from you. Mr. Mohammed, are you with me? Yes, he's here. All right, before I tell you more about this session with Mr. Chris Murphy is with Epic Games, and Mr. Dave McDonnell is with The Last Pixel. These are amazing institutions. Industries. Okay, we have Mr. Hanif Mohammed.
Hello all, welcome to the new world of filmmaking, game creation, which is turning virtual amid COVID. Let me take this opportunity to thank MESC for partnering with Asian Institute of Design in bringing you none other than Epic Games and Unreal Engine along with Last Pixel. Asian Institute of Design is delighted to present you with a rare opportunity to interact with industry's best. Asian Institute of Design is a progressive higher education institution since 2008, offering undergraduate and professional diploma in art, design, and tech. We started as the first dedicated gaming institute in India, then known as Asian Institute of Gaming and Animation. We've been churning out professionals for AVGC and design industry. Our alumni have been contributing to leading blockbuster movies, part of Oscar-winning teams like Jungle Book, credit carried in movies like Godzilla, Avengers, and many of the recent titles. Alumni is part of development of games like GTA, which is the biggest game ever developed. Credits are there in games like Red Dead Redemption, Call of Duty, and many, many more. Alumni has been working in studios across the world: Canada, Finland, Singapore, Malaysia, and all the leading game studios in India. We've been having students from across India, international too. We have had students from Korea, Japan, Russia, Netherlands, and many more. AID's art faculty offers programs in gaming and animation. We'll be introducing VFX programs this year. Our design faculty offers programs in communication design, UI, UX, and we'll be introducing spatial design this year. Tech faculty offers programs in ML and AI, game programming. We'll be introducing more in emerging technologies. We're a fine blend between industry and academy. All our faculties come from industry, again, having worked in studios like DreamWorks, Luxia, and Eccentrics. Being part of few European Union funded projects under Erasmus Plus called MELAs, which are capacity building projects. For more details on us, please log on to www.asianinstituteofdesign.in. Please follow us on our social media handles as well. Now, coming to today's speaker, Chris Murphy and David McDonnell, I would say their reputation precedes them. Chris Murphy is an evangelist with Epic Games, with game development credits across PC, VR, console, and mobile. Chris has over a decades experience with Unreal Engine. He's a bachelor in computer science and bachelor in multimedia, culminating his broad skill set across a range of game development disciplines. Chris' role as an evangelist with Epic Games is to develop independent game developers to build successful games with Unreal Engine 4 through support, training, and education. Then we have David McDonnell. He's a creative director, visual effects artist, and visual effects supervisor with 20 years of experience across animation, video games, documentaries, film, and TV. David is an owner and director of Perth-based animation and visual effects studio, Last Pixel, where he heads the visual effects and TV commercial department. In the recent years, he's been working in film of virtual production, developing VR previz and storyboarding that is used in the storyboarding toolset that is used in the feature film I Am Mother, as well as supervising 260 VFX shots for the film. Join Chris and David as they discuss the tools, techniques, philosophy, and history of virtual production in Unreal Engine, and how David and his team overcame production hurdles in development of the film I Am Mother with virtual production. Without taking any more time, let me put you across all a great and fruitful interaction on the topic virtual production and real-time revolution. Going by what I have seen in the rehearsal, I suggest that please switch on to a full screen mode to enjoy the visual treat. Have a good time.
Yeah, thank you very much for that, folks. We're going to be covering virtual production today, but I'll do my best to acknowledge the fact that we have quite a broad range of people that are here for this session. So I'm going to do my best to kind of treat some things as overviews, give you a slightly better understanding of some of the tools that are in place. And then what we'll be doing is we'll be moving over to Dave. So essentially, the first part of this talk is going to be covering just those wide-level overviews, giving you a bit of an understanding of what other folks are doing within virtual production. And then when we come across to Dave from Last Pixel, he's going to do a full-on deep dive into some of the tools and techniques and concepts so you can better understand how these things kind of all work together in a more in-depth situation. So I'm going to share my screen now, and we'll get going. Cool. Now, I'm just going to make sure that I've got sound enabled as well. Great. So if you have any questions throughout, feel free to use the Q&A section of the Zoom call. So just if you have anything you want to ask for the Q&A time at the end of the session, we'll do our best to kind of move through some of those questions. Now, to begin with, I want to give you a little bit of an overview of who I am. My role for Unreal Engine is to handle basically evangelism within Australia, New Zealand, and Southeast Asia. So my job is helping out developers in all sorts of weird and wonderful ways. That means that I help games people, I help film people, I help all sorts of things. And pre-COVID, I was flying around visiting a lot of these studios. So my backing on this call is very much kind of coming from the perspective of someone who has been working with various different types of teams and using this technology for quite a while. But let's get on with the show. So to begin with, I want to start by thinking about how things used to be. Okay, and that is that you know, when you look back at the 70s and 80s and you think back about the special effects that used to be in like, you know, Star Wars and Jaws and those kind of things, things used to use a lot of models. They used to use a lot of set dressing, et cetera, for their special effects. Now, this meant that there was a lot of control about what was happening on set. You know, like everything had to be physically done ahead of time, or largely done ahead of time, to really kind of ensure that they were going to have the vision that was being set out by the core team. Now, I bring this up because what kind of happened is over time, we started to move into green screening, and we started to move into visual effects that would happen in post. If you're in the film industry, I'm sure you've heard the expression, "We'll fix it in post." And that meant that green screen made it so that like your directors and your DPs could no longer direct and light the images that they were ultimately responsible for. You know, they had to do things ahead of time and hope that how they had initially filmed it and created things would line up quite well. Now, I want you to keep this general difference in mentality in mind for a little bit later in the presentation, but I really just wanted to set that scene now so you could kind of understand how things were to eventually how they kind of became. But for just a little bit of a break, let's talk about video games, okay? So to begin with, I want to look at a game that was in 1991. It was developed by Tim Sweeney for what used to be, oh, sorry, I just got told that the Zoom interface is visible over the presentation. There we go. Hopefully that's better for everybody. So back then, there was a game called ZZT that was made, and it had a language that allowed community involvement that extended beyond simply creating level terrain with the editor. Now, the next game that was released, or not the next one, but the next really, really iconic one was in 1998, which was a game called Unreal. And this is where we started to see the rise of GPUs. You know, it marked the end of the software rendering era, and we started to see graphical quality raising substantially. And over the years, you know, we saw this improve again. We saw modern GPUs coming to consoles. So we started to see this, the overall quality bar of video game engines raise and substantially improve. What we also started to see, though, was this high standard of quality actually becoming cross-platform, because we started to see people's phone becoming, you know, essentially as powerful as some consoles were. And this was another game that Epic made called Infinity Blade. Now, obviously, our games kept progressing until we eventually got to Fortnite in 2017, which I'm sure most of you have heard of at this point. Because Fortnite really represents gaming as a different beast. Fortnite represents multiple devices, multiple platforms. It's all online, it's all social. And it will run on everything from a PC to a phone. It's running the same game across everything. And it has to stand a lot. Fortnite has to deal with 350 million players. It has to deal with 12.3 million people you know, playing at the same time, and across all sorts of different devices. So I bring this up because what Fortnite is like, it's not just a game, it's this massive ecosystem that is also kind of representing where the technology has kind of come these days. And that technology is Unreal Engine. So if you imagine those last few games, they're all built on a single foundation, a single game engine. And what that is all of the tools and the tools and code bases that are required to develop real-time experiences. And it's important that we start thinking about these as the development of real-time experiences rather than the development of games. Now, a quick thing that I just want to mention before we go any further is it's important to note that Unreal Engine is what we call, it's an open platform. And what I mean by that is, as this tool set is growing and being developed, any user that uses Unreal Engine is able to actually make changes themselves and submit these changes back to Epic Games. So if you add a cool feature to the engine that you think it would be really useful for other developers, we can then assess that code and choose to have it. And what this means is it's not just our games that are growing this foundation. It's not just our games that are growing this engine. It actually means that it's also our, like everyone else's games and projects and real-time environments that are kind of helping grow. So essentially, when we're looking at what this tool set is quite comprehensive. It's your world building, your animation, your rendering, your lighting and materials, your simulation and effects, gameplay and interactivity, platform support. All of these things are all kind of like feeding into the same place. But for the purpose of today, the thing that was most influential and most interesting, and what's kind of driving a lot of what we're seeing, is this. Now, if I was to hit play, so I'm just doing this here, and run this, this is what we call sequencer.
You want to play?
Okay.
Now, when it comes to sequencer, I can scrub through this at any point. And if you're from a film background, you'll know how this works. You're already used to this kind of stuff. But what's noteworthy is that if I was to go to any of these shots, I can double click on them, and we can see that this shot is made of various cameras. We can see all of the characters that are in there, the lighting, the props, et cetera, et cetera. But it's important to note that this is running in a real-time engine. So what that means is that if I wanted to, I could drag in a light and I could actually relight sections of the scene. So if I wanted to kind of have this somewhere else, or with different different kind of intensities, or changing these values over time, I really, really easily could. I can grab these things, I can change it, adjust it, et cetera, et cetera. And what this means is that it's much easier for us to work on these kind of cinematics in such a way that we're able to discover happy accidents, and we're able to discover like all sorts of interesting like little shots that we may not have necessarily planned out initially. But this tool, sequencer, is really the fundamental part of where we're kind of going with the rest of this presentation. So it's important to understand that it's this ability to block out sets. It's important to understand that we can not only block out sets, but we can block out shots. We can have all sorts of stuff from previz all the way through to really, really gorgeous looking shots. And hopefully I can elaborate on that as this presentation goes. So with that in mind, what I'm kind of getting at here is that as we're working with Unreal Engine, we're not just working with games. It means that as we kind of bring stuff together, if I bring in a character and an environment, I'm now able to use the game engine to produce still images, to produce videos, to produce interactive experiences. The same set of assets can be used across the board in all sorts of things. And that's a really, really exciting proposition, because what that ultimately means is that game engines have now been able to meet filmmaking. And in the early days, this meant that we were able to develop animatics and previz, but now it gets into some really, really cool stuff. You know, we have real-time visual effects and multi-user collaboration. I'll go into that as this presentation goes on. But for the sake of this presentation, one thing I want folks to understand is that we're going to be using this word a lot, virtual production. And virtual production essentially is where digital and physical spaces meet in filmmaking, okay? So let's begin by looking at where Unreal Engine can be used in its most obvious way and outside of games, which is, you know, we could use animations. So we're going to take a look at a thing called Safari.
Just finished animation and 10 minutes later I get to see the shot rendered. I'm in.
I've never worried so little about rendering on a project, ever.
I think my only regret is that it took us so long to say yes and do it.
So that was Safari, which was a TV series that was made inside of Unreal Engine. And what we're really looking at here in terms of what this means for animation is a next generation animation pipeline, because we have something that's real time. We can immediately test out different things, test out different shots, see what things look like. We're looking at something that's interactive, so it's able to be modified, expanded, or altered dynamically. It has to be immersive, which means that the quality that we're looking at is to aim for something that is of high level, that's equal to or greater than the current animation standards. The aim is to develop something that will be nonlinear, so it doesn't have to be developed in an iterative process like you're classically used to, and I'll go into that in just a moment. And finally, it needs to be customizable, so it needs to be something that can be tweaked and altered and changed. Now, let's consider the current, like your old school, standard, typical animation studio pipeline. Now, how a standard animation studio pipeline works is reasonably linear. You know, you've got that editorial process in that early stage, but it's kind of like setting up dominoes. You know, one pass is being passed off to the next person, to the next person, to the next person. And that means that change is fundamentally difficult. Change is fundamentally complicated to introduce, because to add change means it needs to go back through many different stages, which means that, you know, a lot of this reliance is on that early stage. This is much like the point that I raised earlier about how things had changed in the 90s. Now, when it comes to using real-time technologies for an animation studio, what we're starting to see is Sequencer becoming that core creative hub. So we're starting to see Sequencer become that area where everyone's able to kind of work together and collaborate. And what this means is your final like creative control extends much further through your animation studio pipeline. This means there's much more chance of discovering happy accidents. There's much more chance of introducing all sorts of little concepts and nice little shots that you may not have discovered up until, you know, the final lighting and development. Now, we've had a look at animation, but let's look at something else. And that is that let's take one step further. Let's take a look at film and television. So when it comes to use cases for film and television, this could be anything from virtual sets, VR scouting, pre-visualization of shots, in-camera visual effects, digital humans, and of course, final rendering. So when it comes to this, it's worth noting that as I go into this, this isn't some future hypothetical situation that I'm pitching. And I really want folks to understand that. This is something that is already being reasonably heavily used inside of the industry. Like Unreal Engine has been used in over 120 film and TV projects since 2016. This is something that is already taking off. Now, when it comes to film and television, your pipeline is a little bit different, because by having a real-time technology kind of sitting in there, we're able to more iteratively change the assets as things are being developed. You know, we can kind of we can constantly be revising and revising and revising and revising. And I think instead of me just kind of discussing that, I want to show you an example of how virtual production can be used in the case of pre-visualization.
I came on John Wick as a concept illustrator. I was providing 2D concept art to design the look and the feel of the film. And when we read about a 3-story building entirely made of glass, A number of problems come to mind. You have the reflections, you have the actual structural design of something like this, then you have the look to figure out lighting, etc. So I basically started with concept art using CAD designs from a set designer. I was able to bring them into Unreal Engine so that we could explore it in VR. It became this tool that allowed us to visualize what this set looked like and also helped us to create the lighting and the design of this thing months and months before any decisions had to be made on the physical set. It was such an abstract set that having this kind of spatial relationship and visualizing it from that point of view had tons of value. This set became a hub in the art department. The actors, the directors, the cinematographers went into the VR model so that they could basically visualize everything that was going to be built and seen in the film. I can't imagine them doing this set without VR. This set went through a number of different budgetary designs. I was able to create different set designs within VR, and now suddenly they can see what they can live with and what they can't live with at the hit of a button, and that allowed us to get the set approved sooner than we normally would. When you first walk onto the physical set, it's a surreal experience. It was amazingly accurate. VR has this kind of ability to cross the 2D concept art threshold and set design threshold and give you a real feeling of what it's gonna be like to be there, which is just an incredible disruption in this industry. I came onto the project, 2D artist, and in the end I was a VR developer. The guys at Epic have done an incredible job at making it an easily learnable program, and just being able to quickly and efficiently make something look good in such a minimal amount of time is incredible. So I feel like VR has a permanent place in design, film design, production design. But I also believe that the future is really bright for real time. Every single VFX artist that I know is asking about Unreal Engine. And the reason why is because there's the satisfaction of not hitting that render button, but just seeing it in real time. It's like heaven for a VFX artist.
So let's take a whistle-stop tour through some of the tools that we're seeing for that kind of concept, for pre-visualization and for virtual production in general. The first of these is virtual scouting. So this is a tool that is built into the engine by default, and it allows developers to kind of, well, the virtual scouting tools give filmmakers new ways to navigate and interact in virtual production. So they can move through, they can make better creative decisions, they can see what things are going to look like, they can test out cameras before they're even on set. Artists and set designers can really experience that location ahead of time, and they can develop it accordingly. This is the kind of stuff that Dave is really going to cover in his section of the presentation later on. Next up is Livelink. So Livelink is the ability inside of Unreal Engine to stream data straight into it. What this means is that when you're running something like mocap, or when you're running like just general Max or Maya, you're able to actually stream straight into the engine. And we can actually capture it immediately in the tech. This means that you're not looking at having export pipelines and your mocap actors, while they're doing whatever they need to do in front of you, it's getting immediately recorded, put into Unreal, and you can see what it would actually look like in its final state live. Now, a cool aspect of that is the concept of virtual cameras. How virtual cameras function is you can actually go ahead and you can use an iPad and an iPhone, or you could use a Vive setup to actually move through the world in such a way that you can record shots, see what shots would look like on different kinds of cameras, and push them straight into Sequencer, that hub that I showed you earlier. So here you can see that we're able to just scrub straight through it. Now, one of the really interesting aspects of all of this is that we have a concept called Take Recorder. So Take Recorder allows you to quickly record and iterate motion capture takes. Essentially, you're able to just keep running your mocap tools. You're able to keep running any of your recording tools and just constantly try different take after take after take and incorporate them into Sequencer immediately and try different things. Now, all of this relies on people working together. And when I say that things, relies on people working together, it's important to note that one of the really cool tools that's also built into the engine is multi-user collaboration. What this means is that a collection of people can actually be in the exact same virtual space at the same time, developing it together. Not only can you be developing it together, but you can be capturing, you can do motion capture straight into it. You could be running sequencer as the director is physically walking through the scene while you're playing back the animations and everything else. They can pick up the cameras and move them around. This is a really, really exciting tool set that's completely built in to the engine. The next thing that I want to touch on in this regard is control rig. So control rig is one of the areas that we've been pushing into recently, which is we actually have a in-engine rigging system. Now, what this means is that you can actually bake out and develop your own animations inside of the engine without necessarily having to go back to your own DDC. Now, we've covered some of the virtual scouting tools and all of that jazz. All right, it's kind of cool. But what I really want to cover here is in-camera virtual production. That is to say, how do we actually set things up in Unreal such that it is filmed by the camera itself? So let's take a look at one implementation of that.
Part of what's been fun about collaborating on The Mandalorian with Lucasfilm and Disney is that we have been able to see through a few technical innovations and a few firsts that I think are going to have a lot of impact on the way television and movies are made moving forward. In partnership with ILM and Epic, we have put together a system whereby which we can have game engine, real-time render, and video wall technology coming together to create a backdrop for the big, beautiful world of Star Wars.
The volume is 21 feet tall, it's 75 feet in diameter, run by 7 machines, pumping the visuals onto the screen that's being created in pre-production and can be on the screen within 24 hours of being finalized.
It's incredibly impressive when you first walk out there because it completely surrounds your peripheral vision. And you really quickly forget that you're indoors and you're not out on some planet's surface. It feels like a real three-dimensional environment surrounding you because it is a three-dimensional environment.
You can allow your key creatives to all make decisions together so that the shots are captured entirely in camera, which allows for a better performance.
And what was so exciting about this is by bringing those people together, things started to click. And we started to realize, well, let's not just do green screen and interactive light. If we're going to design the whole set in game engine ahead of time, maybe we could have some in-camera effects.
Everything in the volume is designed to both light the actors and to be a background that we can directly photograph. So you end up with real-time final pixels in camera.
If you look at visual effects heavy films, you've got a film set and then it's going to go to post and it's going to get the world put in. Here we're considering all of that at the same time, and how do we create a background and foreground that live together on the volume harmoniously.
When we started to play with the idea of using Unreal Engine for virtual production, that's one of the things that Richard and John started to embrace, is that you've got this very dynamic world where you can have randomization of things and find the happy accident that gives you the perfect shot. Being able to see the actors point at things and see what they're looking at was pretty transformative. It gave everybody context, with the added benefit that if you want to move a mountain from there to there, you can do it instantly.
You could switch between the Iceland location to the desert location, all within the same day of shooting.
The ability to shoot a 10-hour dawn is extraordinary. To shoot any sequence where you say, oh, this world's not quite right, let's just move it a little bit. An extraordinary number of benefits and advantages for shooting in that environment. It's mind-blowing what that tool is.
What you see is really what you get. And that's something that really means a lot to filmmakers, especially those who have worked with a more traditional approach in the past.
Shots of character in a vehicle traveling through a complex environment. It's always very difficult to do believably on stage. LED screens are a wonderful solution to that problem, because what you're doing is you're taking this technique of image-based lighting that we've been using in computer graphics for years, and use it to light a subject.
And then we would do shoots where we would texture map real lit surfaces onto our game engine Geo, and so the camera could move anywhere. We would do interiors, like Werner Herzog's office. And then you started doing things like building sets into it, having half a spaceship with reflective surfaces. And so it became exciting because by the end of the season, it was like, let's start designing sets around what this could do well.
Just like the good old days.
With Star Wars, we're building on a rich legacy of innovation, and getting to partner with Jon Favreau to make his ambitious vision a reality, it's really a game changer for
Cool. So what we're really seeing there is in-camera effects. And in-camera effects essentially means we're able to run these large TVs, essentially, like these large screens behind them. So those screens are running Unreal. And what happens is the camera is looking at where Unreal is looking at where the camera is. It's then basing what it's seeing and what it should be showing according to that camera position and reprojects that image into the background, which makes it look like things are further away than they really are. But this can be just tied into all sorts of things. And this leads to a technology called NDisplay. So NDisplay is essentially a way of running Unreal Engine such that you can run multiple computers at the same time that are all syncing with one another to power multiple screens. And this means that you can run vastly high resolutions as you need for these types of environments, this type of in-camera effects. You can power them all straight through this. Now, this shot here that you can see on screen is actually a Childish Gambino concert, which took place inside of a massive screen dome. But of course, this stuff doesn't just lend itself to broadcast, doesn't just lend itself to general filmmaking. It lends itself to broadcast and live events as well. So what that means is we're starting to see news channels popping up and actually using, a game engine, a real-time engine like Unreal Engine, to have more interesting and kind of crazy things going on during their broadcasts. In the case of the Weather Channel, they showed it as if the world was flooding while reporting on a flood. So they could give an actual demonstration on how flood waters would potentially rise and what this would mean and how users should be aware. Now, all of this stuff that we see here ties directly into another feature that we have in Engine called Composure, which allows us to do real-time compositing. And if we see how that real time compositing works, we can take a quick look at it here. Into the volume, the world itself, okay? Now, what this means is that as it's kind of projecting the world around, it's also projecting a green screen into what it actually sees. Now, the reason this is really powerful is it means everyone on set can see what the world should look like. However, if the director is not completely comfortable with what's popping up on the screen, they're still able to superimpose what needs to be there after the fact, okay? So that means that everyone has something to react to, and simultaneously all of your reflections and lighting is correctly set up, but you're able to do live compositing after the fact. Sorry, you're able to do live compositing on set so that when a director looks through the viewfinder, what they actually see is what they would want in the long run. They can get a really good idea of what they actually want this shot to really look like. Now, one thing that really helps this kind of stuff is remote control. So we built this in a little while ago, and essentially what happens is you're able to set up Unreal such that you can control it from your own websites. So you can create a little HTTP, like a little website that runs on your iPad or whatever it needs to, that might control the time of day, or it might control where something is placed. These are very clean, simple controls that you can set these up and hand them to a DOP or hand them to a director without them having to worry about understanding how Unreal works. Now, the last thing I want to kind of touch on this side in terms of like how things can be set up is LiDAR. And it's worth noting that the engine now supports LiDAR. Now, I bring this up as well because what you're able to do now is actually go into an area, and you might be using an iPad or you might be using your own tools, but you can actually do a capture of the area and then drop that into Unreal. Now, this isn't for the sake of filming, but it is for the sake of blocking out sets and doing previs with reasonably accurate data without having to necessarily have CAD files or schematics of what the environment should look like. Now, as far as how to actually start working with this data, much like LiDAR, it's worth noting that pipeline integration is something that we've really been focusing on. So pipeline integration, for the most part, is handled by something called DataSmith, which allows you to automatically import many, many different file types, SketchUp, Revit, SolidWorks, Rhino, and it automatically cleans them up and tries to lower the poly count as much as it can and make them more manageable for a real-time environment. But for anyone that's tuning in here that's used to working with USD, Universal Scene Descriptor, it's worth noting that we do have USD support, and you can actually modify USD files inside of Unreal Engine and then save them and push those changes back to USD. Now, I bring this up because obviously that's bringing in your own stuff, but I have no doubt that many of you are looking at this and you're like, okay, but that's, you know, these are very pretty environments and those take a lot of time to create, and you're right. But this is where Quicksort comes in. Now, Quicksort is a company that Epic Games purchased a little while ago. They have thousands of 3D and 2D assets in what they call megascans. And if you're an Unreal Engine user, these are completely free. That means that you're able to just open up asset after asset after asset and populate your world, and there's no cost to this. And these are real world things that have been scanned. These are like real world assets that have been, you know, the Quicksort team have actually found these assets and these places all through the world and scanned them, and then you're able to just drop them into your own projects. It's also supported by things like Quicksort Bridge, which I won't really be going into today. But if you are using UE, it's worth noting that this entire library of thousands of assets is completely free to leverage, which means kind of working with these assets is much, much easier. So the obvious question for like all of this stuff is, you know, what's the cost? And the good news is that it's free for creators. So what does that mean? Well, that means if you're exclusively exporting images or video, there's no royalty attached. If you're developing something that is software and you're selling that software on the store, then we do take a royalty, but it's only after you've made it's only after the first $1 million of gross revenue per product. So if you're selling it as software or a game. Now, outside of this, there is also things such as you can get custom support from Epic Games into what we call the UDN, the Unreal Developer Network. But that kind of support mechanisms is often used by larger studios. Now, as far as learning these tools that I'm discussing today and how these things work together, you know, I mean, obviously at this point, it's easy to look at everything that I've said and say, well, look, there's a lot to take in. There's a lot of tools. There's a lot there. So learning sounds daunting. But it's worth noting that there are multiple ways to learn. So we have the Unreal Online Learning, which I'll go into a bit. We have various education events, industry guides, class and remote training, and I'll cover just a couple of these now. So the first up is Unreal Online Learning. So Unreal Online Learning is it's a website. You just go to, I think it's learn.unrealengine.com, and it's hundreds of hours of free content. Okay, so it's just session after session of, you know, virtual production, stylized materials, how to work with visual effects tools, etc., etc. So I would strongly recommend checking this out because these are really, really robust online courses. You know, this isn't some random person on YouTube that's developing a tutorial where you're not quite sure of the quality. These have all been vetted by Epic and they're really, really robust. So this is completely free as well. Before I mention guides, and it's worth noting that one of the most useful things for any folks that are attending a session like this is the virtual production field guide. So this is available from unrealengine.com/VP field guide. And this runs through a broad overview of virtual production, common setups, information for newcomers. This is a really, really, really powerful guide, and I strongly recommend checking it out. Now, as far as the cost behind developing some of these things, I know that too can also be daunting, and it's why it's important that I also bring up the Epic Mega Grants. So if you are working with Unreal Engine for virtual production or for games or for anything like that, we're giving away $100 million in support for anyone doing cool stuff with Unreal Engine, basically. So this is really, really great because if you're making a project and you've got the early shots done and you've got something that's really kind of resembling what kind of quality it's going to be, you're able to actually pitch to the Epic Mega Grants team to say, hey, we would love to make this, but we would, an extra $25,000 or $50,000 would really help this production along because we could pull in an additional artist for this or a specialist for this or something else, So the Mega Grants the Mega Grants system is a way for helping developers kind of polish their projects and kind of really make them epic, so to speak. As far as what's on the horizon, it's worth noting that Unreal Engine 5 has recently been teased. So everything I've been showing to date has been Unreal Engine 4. But we now support billions of triangles. We no longer have to really care about polygon budgets in the same way as we used to for virtualized geometry. This means that you're actually able to pull over like ZBrush assets into UE and keep them at a pretty high quality. As well as this, we have like fully dynamic real-time global illumination. So the scenes look gorgeous, and and on top of that, we support 8K textures, virtual textures. So again, like the quality bar that we can kind of hit for UE5 is kind of insane, but I'm super excited to see it. I'm going through images because I felt like if I was running a video, it would be framey and not really do UE5 justice. That's what I would like. So I hope this section has been useful. It's worth noting that the next section is with Dave McDonnell from Last Pixel, and it should help put a lot of these tools and concepts and ideas that I've floated into context. So without further ado, Dave, if you want to take the limelight, it is all yours.
Hello, this is me. Everyone can see me, right? And can hear me. And now I have working camera going on and sound coming through. All right, well, I will just, this is me. I'm going to disappear for a minute and share my screen and you will see my talk, and I'll come back at the back end as well, but here we go. All right, so as Chris mentioned, and thanks to Chris for his talk, as Chris mentioned, I'm going to be talking largely about what we've been doing with virtual production and a specific example of what we did for the feature film I Am Mother, which I'm not sure if you have seen it. It's a film you can go and watch on Netflix right now. It was filmed in 2017 in Australia, in the state of South Australia in Adelaide. It was worked on through post throughout 2018 and premiered at Sundance Film Festival in early 2019 and then came out on Netflix in the middle of 2019. Now, it was a completely independent feature. It wasn't one that Netflix financed to begin with. They just bought it after it was made and it turned up there. So what this really means is, as an independent feature, it wasn't something that had kind of Disney budget and all those sorts of things. But we were still able to use things like Unreal Engine in ways that actually helped the film get a higher production value out of it. We'll get into that in a little bit, but I'll quickly just step through and I'll tell you a little bit. Let me get my thing going on there. Actually, first what I will do, I'll play the trailer. Now, I will say that it is a Netflix trailer. It does go for about 2.5 minutes, and there tends to be a few spoilers in the film. So if you are interested in watching the film I Am Mother, maybe look, and you don't want spoilers, maybe look away for the next 2.5 minutes. and we'll come back at the back end of that. So here we go.
Why aren't there any more children, Mother?
There used to be.
Then why did you only make one?
Mothers need time to learn. This facility was designed to give humanity a second chance. One that began with you, daughter. The path will not be easy. The world outside is lifeless. But I made you
Apologies. I just paused for some reason.
into the woman that you are, so that we could do this together.
Mother? How are you unaffected by the contagion outside?
Who put that in your head?
Did you know there were people out there?
I'm as surprised as you.
There's a droid here. Mother's not what you think. She's taken care of me my whole life.
You haven't seen what they've done.
Not Mother.
I told you it was dangerous outside. I hope you see that I'm different than her assailants. That thing feels nothing for you. You don't belong here. I've discovered something troubling. Our guest has not been entirely truthful with us. Daughter, I know you're frightened, but you have no need to be. Have I ever done you harm? It's just a matter of time. This woman doesn't care about any future but her own. She's very dangerous. Dangerous. I'm never gonna hurt you. She's a risk we can't take. We have to go now. Trust me. Trust me. Daughter, your whole life I've taught you to see the bigger picture. Everything I do is to protect you.
Okay, so if you're avoiding the spoilers, you can come back now. So I'll tell some more about the film, but quickly I'll tell about Last Pixel, the company I co-own. We're a very small studio based in Perth, Western Australia. And by small, I mean we're about the size of about 10 to 15 people generally. We started in 2003, and we're a multidiscipline, multi-industry visual effects and animation company. But usually what I mean by that is we've typically made animated content for most screen mediums. So whether it's something you can see on your phone, you can see on a film screen, you can see on TV, you can see on a dome projection, you can see on stereoscopic cave projections. We've kind of done content for most things. Now, we do work across a range of industries as well because of that. So we work in architecture, engineering, interactive, film, TV. And as far as the movie I Am Mother goes, the director, Grant Spatori, I've been a close collaborator of his for more than 10 years. He was a TV commercial director before he got I Am Mother up, which was his first feature film as a director. So we've worked together for quite a long time, and I've visual effects supervised all of his TV commercials as he's been building his career there. So we have a strong working relationship there. And a few years ago, Grant came to us and said, I'm trying to get a movie up. This will be my first time making a movie. We were heavily involved in early drafts of the script, helping the director figure out how he could actually make this for the limited budget that he would have available. So with the film, after the whole late design and pre-production, when she started to look like it was going to be funded and made, our role on here largely was going to be to previz key sequences, previz the set design. And the idea was at the back end, we would probably work on a handful of VFX shots. There were other vendors who were invested in the film and larger places. It had started to get a little bit of notoriety behind it because it made a thing called the Blacklist in the US, which is where the scripts that haven't been made yet in Hollywood get touted around, and it made it onto there, which actually got it a bit of a exposure. And so bigger places were coming out and saying, hey, we would like to work on that as well and investing in the film. What we started doing on iMother was, we did early concept modeling of key mother components. So we modeled early versions of her face design based on Weta's concepts. So if you weren't aware of how the background of this movie happened, Weta Workshop, who are based in New Zealand, as opposed to Weta Digital, they are sort of sister companies, but Weta Workshop is the ones who do the practical effects and Weta Digital are the ones who do the visual effects. Weta Workshop was involved in this, in designing the robot mother, which was built as a practical suit. So every time you saw that in the preview there, that wasn't a CG robot largely. There was a CG stand-in robot for later stuff when stunts are happening, but largely it was a real performer in a real suit that they built. But early on, we were making 3D models of that to prove how it would work in 3D and to get, the director to be able to look at it and see whether or not what translated from a 2D sketch on a page was going to work when he actually had it as a physical thing. We also did 3D concept layouts of the set based on the production concepts. And we started working on an initial VR set preview, which was just bringing in models and actually showing them, which is in a custom UE4 setup. So that's what we started doing and what we were supposed to be doing. But it kind of steamrolled a little bit from there. And what we ended up doing on Mother, I ended up spending personally 4 months in Adelaide, effectively as a solo developer, making the VR toolset that we made, but also covering a couple of other roles. So I was embedded with the art department, running the set previz, building custom UE for VR previz and storyboarding tool. Now, I'll just take a little bit of a side note here to say that when Chris talked earlier, he showed you some of the VR scouting tools that are now built into Unreal Engine. At the time that we were doing this, those tools, I think, were in development, but we actually didn't have access to those and didn't know about them. So we kind of did our own separate custom development around that kind of stuff. So largely what we built, it's all right, I forgive you now. And another thing I will actually point out at this point as well is when I dived on to do this, I actually had very little experience with Unreal Engine. So we had been using Unreal Engine in our studio for a little while, but we'd been mostly just doing art-related tasks. So we'd been bringing stuff into templates and simple scenes that we had in Unreal and setting up renders and doing stuff. We had been building and basing stuff off some very simple VR templates where we could show people around buildings and stuff, which is largely why we felt confident promoting that we could do VR for previz of a set. But when I went to Adelaide to do this, I was largely going to take pre-made models that people gave me, bring them into Unreal and just show them off. There was not a scoped thing at all for us to develop any tool or develop a very rich tool set and make it be what it was in the end. And so, as I was saying, my experience on actually using Unreal to do any coding at all was very limited. So within this 4 months in Adelaide, I went from almost zero knowledge apart from importing stuff in Unreal to actually being able to develop something very useful for a feature film. So apart from the Unreal Engine side as well, I was also doing CG lighting studies of figuring out how the robot would look when lit by the set we were proofing. I ended up doing key prop concept design and modeling, and I'm not a prop designer. I just ended up being the person because I had access to the tools and could do things very rapidly in real time and not wait 2 weeks for something to happen, that I ended up getting given the task of, can you mock up something that the director likes that then the art department may agree or not agree to build. And then also other parts of that involved me tweaking what the set concept design modeling was to sell back to the production department about whether or not that was a better idea. Now, at the start, I did say I was meant to be doing previz. We did some previz, but largely what I ended up doing, which is an interesting point, I think, in terms of doing this sort of thing on an indie scale, instead of me doing the previz myself, what I did is I built tools that let the director do it himself. And what this meant is the communication line on the director briefing someone to do previz and then them going away and doing it and then coming back, there's a lot of loss in that. But by giving the director, who is very hands-on and very technology forward, the tools to do it himself and explore things and come up with the ideas himself very rapidly, that ended up being a very, very powerful idea. On top of that, we ended up doing the edit for the film was hosted at Last Pixel. We ended up doing post-viz and edit temp comps, and we ended up doing 255 visual effects shots, mostly hidden stuff. And there was a team of only really about 4 people in post doing those 250 shots. So Some of them were simple stuff, but we actually ended up doing a massive key sequence, which is a surgery scene. We ended up directing mocap sessions and stuff for all of that as well. Now, I've probably largely explained a little bit of this while I've been talking about the other stuff, and probably should have been doing it while you guys could actually see some images and not just some text. It generally started life as a VR set viewer, and like I said, and we brought in real film cameras and lenses into VR. And what this meant is the camera we were going to be shooting on, we matched what the film back would be for that, we matched what the field of view was, and we only made it accessible to use the lenses we would really have for the film. And that meant that anything we looked at in VR through the previz tool, we were confident is how it would look when we actually shot it. We built standing actors, which were basically posable characters that we could actually frame up. And I will point out that a question that does come up quite often is, did we do mocap and did we actually record stuff? We had working demos of that working, where I was actually wearing a mocap suit recording stuff and then playing it back and being able to run the camera on it and make up scenes that way. But for a very small indie production with a very small team and a very rushed schedule, what we found was the live mocap, although really exciting and useful, was only like 10% more beneficial than the larger thing, which was actually just being able to walk around the space, block characters in and shoot stills. And so we ended up sort of sidelining that and focusing all our attention on what we could do by just actually posing characters, taking shots of them and figuring out how the blocking would work that way. We also end up having to reproduce every script prop. So anytime anything is mentioned that someone touches or moves in the world in the script, I had to have a digital counterpart for each one of those. And largely this was done by me just finding free assets through the Google SketchUp 3D Warehouse or other assets libraries that I had lying around, bringing those things through. We made a readable script in there so the director didn't have to take the headset off to come out and read the script to figure out what happens in the sequence next that he's storyboarding. And we built a save and load system that was effectively a contact sheet of all the storyboards, but you could load up any previous scene that you had been boarding and just make changes to it, and it would automatically work that way. It ended up being much like the John Wick example that Chris was talking about earlier. It ended up almost by accident being a central hub, this little reservoir of knowledge, but also the sharing and conversation that would happen around what needs to happen next. Because the director was spending so much time in VR planning and looking at things and figuring out what the set's going to look like and approving art assets, it ended up being where the production designer, the DOP, the art director, the gaffer would stand around and plan what they were going to do in terms of finish building this set, lighting this set, and how they were going to work day to day on it as a shoot. So what started as something which was almost accidental at the start, that this was even involved in the process, became a very, very key component of how the film was made and how the production value that it shows, was achieved. So without further ado, what I will do is, this is now, I'll just go and find where I need to click. This is a video demo of the VR being used. Now there's a little bit of a preamble of just some nice, beautiful shots. But very soon we'll get to the point where you can actually see this being used in action. And I'll kind of go through and describe a little bit of the mentality of why we did things a certain way and how we arrived at them. But as I was saying earlier, I've been working with the director for quite a long time, and very early in the piece we've been saying, we think VR will be super useful for this because we've been using it for architectural stuff and all these other things. And as soon as you have the very first basic idea of what the set looks like, there is so much to be learnt by looking at that and using spatial skills by bringing it into VR. And he was curious. I wouldn't say he was sold on the concept of that. He'd already been doing stuff in 3D on his own computer a little bit and knew the power of doing stuff in 3D. But at this stage, VR was still a little bit of a novelty and he wasn't exactly sold on how it would be. But we said, look, just send us the sketch and we'll put it in, and we'll just do a really, really quick hack to put it in. This is literally that very, very first sketch they sent us, which was them looking at the floor plan of the studio, sketching out and color coding it and putting it in there. Now, within maybe a couple of hours, we took that initial sketch and we brought it into 3D, we brought it in at scale, and this is it here. This is literally a one-to-one match of this just as a floor plan. And they do this in studios. When you do a studio shoot, people will go and tape out on the floor. This is just the VR version of that tape out on the floor, except we've also extruded up some very basic idea of where the walls are. Now, this is looks like a very early Doom level. This is so basic, but the knowledge that was gleaned at this point from bringing this into VR and being able to move around was actually immensely helpful. If all we did on the project was even this, it still absolutely would have been worth it. I will just draw your attention a little bit to what we're seeing here, which is where the director is actually lining up very two bad stand-ins of a very early Mother previz model, because this is the only thing we had that was posable in there at the time, or movable. But he's posing these two characters around a window scenario. And we'll come back to that later, because I think there's an interesting point about things we learned from the very get-go and what flowed through to what actually happened in the film and what ended up getting shot in the film. Now, after I went to Adelaide, after we'd playing around with the VR for a little bit, I was meant to go for 2 weeks and just help them. But one of the first tasks we ended up doing was trying to design what corridors would look like in this film. And as anyone who's probably ever worked on a sci-fi feature will tell you, like the sci-fi corridors are a huge part, actually, of how everything hinges around the design of how they work. And ours was no different. We had what was meant to be a vast underground bunker to design that was meant to look like a giant catacomb with kilometers of places you could run. But we didn't have kilometers of corridor, and the beams around the side repeat. So working in there and looking at the space was half the conversation, but then the other part was, well, what does our virtual camera do? So here's, as I was saying before, this is our virtual camera system. We actually, somewhat blocked it on a physical camera. We replicated the actual shooting format and the lenses we would shoot on. I will point out, just for the sake of completion, that the f-stops we used here weren't 100% accurate to the lens we did. It was a rough approximation, but the field of view and lens lengths and everything were the things that were accurate to the lenses we would shoot on. But this was super valuable looking through the camera in this VR space, because your human brain that's used to living in 3D spaces and your spatial awareness could be used, but you could also see what the camera would see. And we could make design considerations about, can we even see the ceiling in a particular room? Can we see things from different parts of the corridor? Can we save money in places? And this is a case in point. Fast forward a few months later, this is the entire set as was built in CAD, or should I say designed in CAD, exported out, brought in through 3D Studio Max and into Unreal Engine, which was our pipeline at the time. There are tools now in Unreal that Chris can apologize to me later for that weren't around at the time, that we were doing things manually. So I built a lot of scripts about how to really batch process a lot of things. So if the art department had redesigned a new version of the set, pretty much by about 4 hours later, I could have the whole thing completely updated and referenced straight into Unreal. So it was that fast for us to be able to turn around very, very bulk changes. And yeah, so the director could navigate around an entire set that wasn't built yet. And I'm talking accurate down to those things on the ground were actually plastic pallets we were getting in bulk, buying from another state that we could get really cheaply that would look like, interesting floor panels, but they were cheap plastic. But we replicated those in 3D. Everything was CAD accurate. All the props and things were accurate as well. And even down to, because it's a game engine, we can make things interactable, but we made things interactable that were the things that could move on the set. If you could open a door on the set, you needed to be able to open or close that door in the VR environment, because you needed to create storyboards in open door state, closed door state. And this is now a progression to fairly far through the process where we had a fully fledged storyboarding tool. So now we have our stand-in actors. The director can actually plan against key props that are being made that are all interactable. So these are these little embryo things where embryos are stored cryogenically, and a robot can take them out and place them in a machine and have them grow. But that whole frozen embryo prop that's down there was actually interactable. If you clicked on things, they would all come out. You could move things in and out. You could grab things, but you could pose the character, take shots. Just then we actually saw the contact sheet, which was also served as the save and load game feature. Anything you saw as a picture in that contact sheet, you could load up and return back there. Now this is actually a reasonably high poly model, but definitely crunched down version of Weta Workshop's actual digital files for the creation of the mother model. We turned it into posable characters. The other digital characters were stand-ins for the real actors. They were built to the heights of the actual actors, but they were effectively just very easy to make Adobe Fuse characters. So they were free to make, built them in Adobe Fuse, exported them out, got them as close as we could for something that would give us the most knowledge for the least amount of time. But here you can see this is the camera view of those things being, the witness camera view of those things being posed. And you can also see we actually had lighting in there. Now it wasn't super accurate lighting. What it was indicative lighting, because this was built in 2017. It was all running on a 1080 Ti, and we weren't doing any baking lighting process because that was going to be a slow process. It would have given us more accurate lighting. We could have got a really, really glorious look, but it wouldn't allow us to make bulk changes really quickly. So what we focused on was putting some basic dynamic lighting tools in there, and probably stretching as much as this video card could handle to VR of how much dynamic lighting you could do at any one time and still maintain frame rate. But what it was about trying to convey mood, tone, and intent from a design purpose from the director that he could share with the DOP. And the DOP would say, this is how I would really light it. Fast forward the process, we'd spend all this time inside a studio actually filming and doing the VR previz for a studio shoot. But Grant had an exterior shoot that was going to be shot on a New Zealand beach. And he was saying to me, I don't really want to go back and do old school traditional storyboards now. Can you build me a New Zealand beach? And as I pointed out before, I didn't really know how to use Unreal Engine that well when I first started this process. So I had to go away and say, I'm not sure, I'll have to have a think about that. And a couple of days later, I found out where I could get some free satellite data of the particular New Zealand beach from the New Zealand government. Went away, got that data, brought it in, taught myself how to very basically use the landscape tools to make them accurate to a real location. Didn't focus on necessarily the believability of where every tree, etc. was, but we focused on what the actual geographical location would do. And that's down as well to time of day with the sun tracker, which is very important for shooting on a real location, where this is all referenced to the actual time of year they're going to be shooting and the days and what the sun would actually be doing on there. Now, this is a tool that is wasn't around at the time in terms of sun and sky, but is now built into Unreal as well. So we had to kind of replicate our own version, but sun and sky, accurate geolocated sun and skies is now a tool that is pretty much built in. And the interesting thing about using VR for this as well is was going to be shot on a real New Zealand beach. This is the beach in question. But a lot of the CG elements weren't going to be there, such as the shipping crates we just saw there, or all of these robots here. But Grant still needed to figure out that kind of mishmash of what would be on the real location and what would be CG later, and come up with the ideas of how that would work. So that was largely how we ended up storyboarding this, or how, I should say, how the director storyboarded his own feature film in tools that we just made. And you ended up with some really, really striking images out of it. And it meant that you could get there quicker. You didn't have to try and figure it out on the day during the shoot. The director actually went in with a solid plan and a solid idea. The video is just about to wind up now, and I will just skip ahead to some frames, but there's a couple of points I'd still like to make. One of the questions that often comes up is people say, well, aren't you locked into what you filmed there because like what you storyboarded because it was so accurate? And we actually found the opposite to be true. What we found was by the director being planned and knowing what he could do, it actually freed him up to know what he had the flexibility to change on the day. If the DOP said, what if we were over here? The director could say, well, I tried that in VR and either I did like it, that idea, or didn't like it, but he knew what was on the table and what was off. So he went in with the confidence knowing what he had the flexibility to be adaptable on. What I will show now is just some comparison frames. And these are comparison frames between what we storyboarded and what ended up in the film. So here's what the director storyboarded himself about the framing of how this might look in shot. And then this is what basically ended up in the film. So they're similar. We're shooting from very similar locations, but there has been flexibility on the day and a few changes. And you can obviously see now it's beautifully lit and all the props and everything look amazing. This is one of my favorite ones. You can see it's actually quite blocky, and the little tiny embryo is this tiny little cheap polygon thing because I had to make thousands of them be there. But things like the depth of field in the frame from a storyboard point of view actually conveys a lot about the filmic process and what you would intend to shoot. If you didn't actually have the depth of field in there, the composition is entirely different about what's readable. It becomes a bit messy. And now you can see the actual shot. The robot is even more out of focus on our anamorphic lenses than was intended in the storyboard, but you can actually see it. It holds fairly true. I will speed through these a bunch. We did actually have some post-process stuff as well where we could actually spit out these storyboards as sketches, but we actually found spitting them out as the colored ones with depth of field and everything was actually super, super useful. This is an interesting frame as well to talk about the process, because we always knew this shot was going to be in the film well before we knew what the set was going to be around it. And through different design iterations, we actually changed what is behind there in terms of things like the light well, how that composites, things like the pillars to the side and the symmetricality of this shot. Largely, this was a messy design early on. I don't actually have versions of that early design, but things changed on the set purely to accommodate this shot and how this shot would work. And then you can see the final one in the film. It's a very almost like Stanley Kubrick, very central symmetrical shot, which was intended. And if things were kind of slightly out with it with the design of the bench and the pillars and the background, it just wouldn't work the same. So earlier on, I said, remember this point when we, very first day the director was in VR, he was blocking out two very, very bad maquettes of characters around a window. Effectively, he was trying to achieve this shot. As part of the script, two people talking through a glass window. Now, this is probably the shot in the film that had probably most of the changes in the design iterations of what would happen to the set. And if we hadn't have done it in VR, we wouldn't have been able to A, find the shot, and B, know the constraints. Originally, there was going to be a pillar in front of this shot that would have cut off that looking down the line of glass. And the director was like, I really want this shot. I really need to be able to achieve this. Can we get rid of the pillar? It caused some engineering nightmares about how we were going to suspend and cantilever a pillared roof in this box corner without, it causing problems. But it was a problem worth figuring out early rather than during construction or once it's built and going, oh, damn, I can't get that shot I really want in the film. And here's the actual shot from the film, looking completely down a piece of glass, seeing the two characters mirrored either side effectively. One of my favorite shots in the film. And again, some of the more evocative shots in the film and how they were storyboarded before. So I will speed through these, but you can see how the director could very rapidly find the vision of what would look great within the space, what he wanted to achieve, how it would achieve from story points, but also just communicate that to the rest of the design team about how all these decisions will impact throughout the movie. The stunt stuff, how that's going to be achieved, lots of the key drama moments. Sorry, I am speeding through this. I'm just trying to save a little bit of time. Hopefully this conveys a lot of the design intent and then what was shot. This is an interesting one as well. So this was the design intent. The robot's meant to run into a room and scan a big laser. Turns out you shouldn't really point lasers at expensive film cameras because you will burn out the CCD on them. So the shots are different, the robot facing the other way. But again, like there's flexibility of the design changes. So that was what was storyboarded, but that's what ended up being changed on the day. And it's still equally a really, really great shot. And even with the bad lighting, you can see that the intent was carried through from design to execution. And some of these get a little bit repetitive. We've kind of seen a bunch of these. So that's what we did in 2017 on the feature film I Am Mother. As I said, we also did a couple of hundred visual effects shots as well. To tie into some of what else Chris was saying before about virtual production, we've continued on with that. We've been doing a decent amount of our own R&D towards what else can be done in virtual production. So as Chris was talking about before with the in-camera stuff, shooting on LED, not everyone has Disney budgets, etc. But we have been doing a bunch of interesting stuff that way ourselves. I'll quickly play you a video from a little sneak peek of some of our R&D we've been doing. I will just turn it down and talk over it actually. So this is shot on about 29 meters of LED panels.
Turn it down a little bit further.
Okay, I will. Thank you, Chris. There we go. Is that better?
Much better. Moody.
Yeah, so this is shot on LED panels with Unreal Engine, working with N-Display, which is a plug-in layer that sits on top of Unreal Engine. To throw all of these things on any screen format basically and respond to camera tracking and figure out all the projection. So these were a set of test shoots for this particular one around figuring out how SimTrav would work. So when you've got car shots, and actors in cars, which is largely a pretty tricky thing to execute and be able to reset and go back to ones and, you know, just actually get the drama with the safety of actually traveling on real roads. So this was a fairly rough and ready tech check, I guess you could say, or you know, shoot that we did to just see what the screen would respond to. And it was a fairly basic test from, you know, our point of view, but it was really super encouraging about how convincing a lot of this was. Now, there are other examples of stuff we've been doing in terms of this R&D that I've got some links at the back end of the talk when we just get through this next little bit, and you can go check them out on our YouTube and Vimeo page.
Are those Quicksort assets, or did you pull it from the marketplace?
So the background for this is actually just a marketplace scene called Burn Forest. I think it cost a couple of $100. It was probably the best one I found that I could quickly get. But largely our testing on this, we concentrated not on the actual content creation, but on how to execute getting it working within Unreal, but also the stagecraft of how as filmmakers you do work on the stage. And we learnt a lot of valuable lessons. There's some more videos coming out from me, sort of tutorial stuff coming up. There's one I've already made you can find on our YouTube. I'll show the link in a second. Now, these are the links that if you want to quickly copy these down before we pop back to camera, etc. So that's just our website and our YouTube and Vimeo addresses. There's slightly different content between the YouTube and the Vimeo at the moment. We are mid-migration of some of our stuff from Vimeo over to YouTube, but the tutorial stuff is actually is going to be more live on the YouTube page. So that largely talks about.
I had a couple of
process.
questions. I had a couple of questions just pop up about that scene. I want to stress to people that what they were just seeing was real people on an animated world. So the car was real and the person was real, but the environment that they were driving through was Unreal Engine. So that's actually televisions in the background, displaying the world.
You can see it here. Probably if I go to this frame.
Yeah,
that's pretty much the setup.
Yeah, so I just wanted to clarify, because I think some people thought that maybe he was fake too. And I want to stress that, like, we're actually doing real-time compositing. Well, Dave's doing real-time compositing. I didn't do anything on this.
Yeah, but I think even real-time compositing is potentially slightly misleading on that, in that it's all completely in camera, where I'd say real-time compositing is where you are probably keying something out and putting it over. But that's, you know, that's a terminology nuance.
That is, I'm sorry, it's in-lens effects. You are completely correct.
I will stop the screen share now and come back to the video.
All right.
So yeah, that probably concludes my part on talking about this. I mean, hopefully that's actually been useful to people in the audience. A thing I would like to point out is, again, we have been doing this not on Disney budget. We've been doing this very much on indie DIY kind of level of you know, absolutely making it up as we go along. But I think it points out, because Unreal Engine is free for this type of usage still. Keep that fingers crossed for that that's the case, as in going forward. But there's so many learning materials out there. Yes, there's a certain level of skill that you need to build through doing it, but we found that as a team that it was a very useful tool to very quickly be able to do things that not necessarily were going to be exactly how you do them if you're building a game and you're spending years, but you can very rapidly do stuff that's going to give you answers for making films. You can do stuff that's very rough and ready and very dodgy in there that will actually help you make a better thing. And that's largely what we concentrated on, is how can we get to answers the quickest way possible? And then we go away and hopefully make good stuff.
That was great, Dave. Thanks a lot for that. Do you mind if I shoot some of the questions over to you that are more relevant to your side as we go through? Is that all right?
I shall try my best.
Sure. I guess there was one question that's come up. A few people asked it actually, but essentially what they're asking was, do you feel that the virtual sets add to the expense or save money in production itself?
I actually think that's a really, really interesting question. And it is one that came up during the project of people going, is this saving money or costing money? And my answer is there's no way to really know, because to know, you would have to have a control where you filmed one version of this movie that did this process and one version that didn't. And no one's ever going to go and do that. So we only have speculation and guesswork. I do believe that it did save the production money. How much it's absolutely impossible to tell, because as with most creative endeavors, every time you save money, it's not like the money gets put away somewhere else. The money basically gets reinvested into what's on the screen. Yep. So what it didn't exactly save money, but what it really did is it meant that every dollar counted. So every decision that could be arrived at sooner meant that something else could be built. Every problem that was identified meant that that didn't cost money on the day, so it didn't have to be one of the producers and accountants' nightmares about trying to figure out how they could afford something else in post. So every dollar that was meant to be spent, and more, because probably most movies do somewhat go over budget, ended up on the screen. I think it's an easier statement to say that the director managed to much more easily arrive at their vision and put every piece of their heart and soul and every dollar that could throw towards what we see on the screen, instead of being spilt on the ground as mismade stuff that got knocked down and rebuilt, or ideas that ended up on the cutting room floor because it didn't look very good. We knew what went in. We had a solid plan.
Cool. So more bang for your buck is the
I think so. I think so. I mean, look, but you could use the technique to save money and actively do that and account for that and be like, well, we go. But anytime you have gone in with a plan, the more planning you have, the less waste you will have, the more you'll be able to know where you can save money. I know we save money by not building roofs in certain places, but that money then just got spent elsewhere.
Your point is the budget's always going to get used regardless, but this helps minimize.
Yeah, I think it's the same as render power in any render farm scenario. Like if you upgrade computers to get faster, you don't make things go faster. Within 3 months, you make things go the same amount of time they used to go. You just get more stuff on screen for that.
Cool. So there was a couple of things that had popped up. Unfortunately, Zoom does not let you comfortably copy and paste the text out of their Q&A section, which I did not expect. This question I think is good for both you and myself to answer, which is, how do you go about getting into the industry? Like, how do you go about getting into virtual production? I feel like it's worth you answering your side and me answering my side, because I feel like it's more about getting into real time and what avenues, like where your first port of call could be in different ways.
It's always a difficult question in that, you know, I have a 20-year career. So when I got into the industry is a vastly different story now than how people now could get into the industry. I think the thing that stays the same is always having a good portfolio. I think no matter where you try and apply for a job, effectively what they want to see is that the work you are showing them shows that you understand the kind of work that they do. So if you're applying for a company that doesn't do character animation at all, it's probably not useful you showing them character animation and saying that you don't care about character animation, you want to work on spaceships or whatever. If the company you apply to does spaceships, show them that you do good spaceships. It shows that you've researched the company and you think you're a good fit for them, but it also shows the gap, or, you know, what quality of work you can provide and how well you might fit in with that team. So that's the first thing I'll say in that. The second thing I'll say is the convergence at the moment between how things have typically been done in post and how they will be done in the future. At the moment, the convergence is around real-time technologies. So with the virtual production stuff for film, etc., like that, learn a game engine. Throw your time behind learning a game engine. Find your particular skill set and how that applies to there, and show that you can do cool stuff in there.
Sure. I think adding on to that, like, it's worth noting that getting into this industry is an interesting one because there are so many different roles in making a game. There are so many different roles in making a film that all can still tie into virtual production. So, you can get on board as a visual effects artist, but you could also just be getting into it by being a bit of a generalist. I mean, someone that can cobble together, things together for previs can actually be more useful at times than the world's greatest visual effects artist, because you can get someone who will make like incredible explosions or fire or whatever, and that's great. But sometimes what you need is a director is going to be like, hey, can we do this? How do you think that would look? And someone that can do something that is just really quickly throw some lights into the scene, get the cameras together, get the shots together, and be able to just really quickly, to a director, be like, this is what it would roughly look like. And they can be like, this is a terrible idea. I'm not doing this shot. Or they might be like, this is a great idea. Let's continue on down this path. Someone that can actually quickly iterate as a generalist can be a really, really powerful person to have on set. So don't feel like you need to become the world's best character animator or the world's best programmer or whatever to kind of get into this industry. There are a lot of avenues to kind of go down. And like you can also move sideways from other industries too. Now, I've had about a dozen people kind of ask this question, so I'm just going to quickly answer this one. A bunch of people are like, yeah, but how much does it cost? So Unreal, if you're producing movies and stills, it's free. There's no professional version. There's no pro version or student version, which a few people have asked about. The version of Unreal that you download from unrealengine.com and you get into the launcher is completely, it's free to download. You can pull it down. And even if you made an entire movie, and if you're outputting just the images and the video and the audio from it, but you're not selling it as a game or as something that's interactive, then it's free for you to be using. So like this is accessible. So a question that we've had, Dave, do you have access to the Q&A section that we have?
Yeah, I'm just starting to scroll through it now. It's rather extensive. There's a lot of interested people out there.
Yeah, there's 60, 70 questions. If there's anything that you feel like you want to jump on, go for it. Someone said, well, how do I get started in Unreal Engine and how do I actually start learning it? To that end, I'm just going to quickly share screens again. Oh, man, I'm going to minimize the Q&A. All right, share screens. So that's coming through. Did I select the correct screen? You are seeing the Learn tab?
I can see the Learn tab. Yes, I can.
Okay, good. I thought I may have shared the wrong one for just a moment. Okay, so if we were to look at this, if you go to the Learn tab of the Unreal Engine launcher, down here you'll see Engine Feature Samples. So Engine Feature Samples is literally just projects that are completely free to download that you can just pull apart and rip apart and examine and study and do whatever you feel like. So these are all completely free projects. There are entire games. There are some older samples here that you can suss out as well. But these are a really, really good thing to kind of pull apart. The one in particular that I want to highlight is content examples. So content examples is this. So let's say you wanted to get a better idea of how we go about putting together environments that were to do with putting together a level. Okay, I can actually open up the level called Level Design Workflow, and what we can see within this is this area here. This area here represents what our very first passes look like. We've just got base environments, very simple geometry, et cetera, et cetera. The next thing that happens is we can see that we've got the meshing and we can study how all of that is put together. We can then see the first lighting pass, followed by the polish pass where we start to get things like these effects happening and little flames, et cetera, et cetera. So being able to kind of open up this content examples project is super useful, because if we wanted to study, say, skin rendering in Unreal Engine, we could open this up and we could actually examine different types of materials and how those are set up to correctly render skin. It's just compiling shaders because I did not build this ahead of time. So we can see, we can study this, and I would be able to click on it and open up the material for it. Oops, I want to open the base material. So So, I can examine how this has been set up and how they're getting these kind of maps. So I just want to stress that this is a really, really powerful kind of thing to have. Now, on top of this, we have the entire online portfolio that I showed you before, the learn.unrealengine.com, which is really, really powerful because it's just video after video after video after video of just free courses that are literally teaching you how to get into virtual production, how to use Unreal, how to build worlds, how to stylize scenes, et cetera, et cetera. Like, I can't stress it enough that it's there and it's made for people to get used to. Someone said, Chris, why Unreal and not Unity for virtual production? How I would answer this is best described like this. Everything you need to get into virtual production is built into Unreal. Okay, the virtual scouting tools are there, end display is there, the resources are there, and the quality bar is there. Like, you can look at what Unreal is doing, and we're pushing all the way from previz work like Dave's through to things that are actually the final pixel, that final quality bar. And I think that's a really, really exciting perspective because it means that this entire range is there from start to finish. The final output of what you see in the cinema can potentially be coming straight out of Unreal. But for folks like yourselves, it's not going to cost a dime. And that's just super accessible for everyone. But not only will it not cost you anything, it's like the tools that you can leverage from here are not only industry standard tools, but they're all built and maintained, or built or maintained by Epic. And that means that you're not relying on any third-party plugins. You can actually have a really robust software suite straight out of the box that is being used on actual productions, that is being constantly stress tested. And you can leverage that. And that means that you can just, every time, we've worked on these projects in the past, it allows you to stand on the shoulders of giants and see much further and do much more. And I think that's a really, really, really exciting prospect. And that's why, I really heavily push UE on this. And as I said, like, as far as accessibility is concerned, there's no pro version, there's no student version, there's no indie filmmaker version that we're going to be selling you. So hopefully that helps kind of clear up that side of things.
I found a couple of questions, Chris.
Yeah, go for it.
And I actually might need your help with one of them because I can't remember one of the suggestions I'm about to make. Somebody did say, can you suggest any previz softwares or guide for filmmakers? On the previz softwares, I think if you look on the Steam app, you can find CineTracer, which Matt Workman, who is a DOP, he's actually one of the people you do see in some of the behind the scenes videos when they're on the LED stage in Chris's talk. He has a commercial app that you can buy called CineTracer. It's largely made for DOPs and other filmmakers to put characters and lenses. It's much like what we had going on in VR. The app does largely focus on high performance, less VR and more actually on the desktop because it wants really high rendering quality, but you can fly around there much like you can in Fortnite, but you kind of do making the film the game kind of thing. And it's a really good way of actually, from a filmmaker point of view, to actually figure out your shots and your coverage and your lighting and what you might look like. I'm not sure if you can import your own assets into it yet, but there's definitely some pretty elaborate prefabs. And then the other one, I cannot remember the name of it, but it's fairly recently out, previous set of tools from the people who did the his Dark Materials stuff. They're a UK group, and I cannot remember the name of it right now, but they have released a free tool that you can download for previz. It is on Steam, and I just wish I could remember the name of it right now. I'm very, very sorry. If you Google Unreal Engine, his Dark Materials, you will absolutely find articles, what they are talking about and all of that. So.
I think I've had another question come through that I think is really important to answer. Someone said, well, isn't won't Quixel make artists out of work? I want to stress that Quixel is real world scans of actual things that exist, but there are plenty of things that you want in a film that don't actually exist. And the exciting part there is Quixel allows those artists to be leveraged to either use it as reference points or to use it as something that they can build upon. So if you think about an entire world that needs to be made, there's a lot there, right? And Quixel will help you get this far, but quite often you still need to go that extra step. So being able to let those artists kind of put more work into developing, putting more work into developing the actual content that really matters, while all of the fundamentals like rocks and trees and ground and such are just kind of handled for them, kind of empowers artists across the board. But being able to pull those assets too, it might be a letterbox, it might be a wall or whatever, and giving them actual visual reference to build the rest of the castle or house or whatever it may be is also super powerful. So I think you need to look at it as a supporting technique rather than necessarily a rather than something that is competing with those artists traditionally.
I think I'd like to add something on that as well, actually, Chris, in that it's similar to what we were talking about before about, was there money saved on the production? And I said, well, the production value just got bigger. Do you know what I mean? Like the budget stayed the same, but the production value increased. And I think things like, Quicksort, Megascans does that sort of thing. If you were going to build an expansive environment and much of your budget was going to be spent on replicating rocks and getting hundreds of artists to just build rocks and trees and all of that sort of stuff, if you can get those rocks and trees for free and still use your artistry to build a nice world, what you will end up doing is throw the production value you would have thrown at artists building those things into building a bigger world or a more expansive world, or adding stuff to your movie or your set that you otherwise wouldn't be able to afford. You can grow that world more. So, I mean, I still stand by, like, the budget doesn't really diminish. It just turns into more production value that goes other places. And the artistry just gets applied in other places. If you're removing some of the menial tasks that you can get a really good result for free, you will apply the artistry in other places. And now Chris is frozen for me. I'm not sure if he's frozen for everybody else. Or maybe I froze.
I think we're good.
Yeah.
One of us froze. All right. We've got time for just one or two more questions. Is there anything in particular that you want to jump on from the set that we've got here, or should I?
Somebody asked a question. I think it has scrolled a little bit now, but I think I can remember it. I think they'd said, like, do you think the movie would be any different with the tools released later in UE4? It's actually a question that's come up a bit lately, especially with the newer sets of R&D we've been doing with end display, in that if we had the in-camera stuff with end display, like I Am Mother largely didn't have a lot of VFX. I know we said we did a lot of shots, and there's still quite a lot of shots in the movie, but like I said, we had a real robot. We had largely a real set. We did some very basic digital set extensions and fixes, and there was a lot of VFX done in the exterior part to make the world look different. But it wasn't shot on lots of green screen and stuff like that. It did have an ambition of largely achieving things in camera. If we have had LED walls, and if we had end display, I think we still would have built about the same amount of set that we did. We wouldn't have backed off on building sets into shot virtually. But what we would have done is we would have used LED walls strategically in places to expand that world. We did have entire sets that were meant to be realized from the script that were very big, expansive underground areas that ended up getting cut for budgetary reasons. And I think some of the newer virtual production techniques would have actually allowed us to have achieved those things and kept them in the movie. They wouldn't have been written out, because we could have gone, we can have our cake and eat it. We could have done a lot of those things, shot against LED, and done some other digital set extensions and stuff on, because we would have been able to get a lot more stuff in camera, because that was, again, one of the prime things is for the productivity in the budget line, a lot of it's had to be fairly non-post shots, or at least a large amount of shots that could achieve it that way, and then spend the money on the key visual effect shots. And I think things like that could have allowed us to have done that.
Yeah, that makes a lot of sense. I mean, like, it follows with what you said before, and that is that if the money is getting put in regardless, it allows you to kind of expand what's there. Now, we have run a little bit over time, so we should be, I think, winding it up there. Is there any last advice you'd like to give to any folks that are getting into virtual production at all?
Just play with stuff in real time.
Play with stuff in real time? Sure. My main advice is just start checking out the tutorials and start checking out what people are making. So I hope this session has been useful to everybody. And I hope we've managed to kind of clarify like some ideas and concepts that are floating around the industry today. I hope it's been beneficial. Thank you all very much for your time, and thank you to AID for hosting the session. It was great fun.
Thank you.
Siva, did you want to pull things back, or?
Yeah, I think Ms. Pooja will be jumping in.
Great. Pooja? There we go.
Yes, thank you so much, Chris and Dave. You have given us information of entire other world, I'll say, the Unreal Engine. So I'd really like to thank both of you for your precious time you've spent with us, for our students watching you across the country. And we are glad that you are on the platform of Vidyadaan here. Hearty welcome, and thank you so much. And guys, thank you so much for attending this session. And as you all are aware, we have Creative Me campaign going on, so you can showcase your creativity. Like animation courses are now also available on, Vidyadaan. So you can showcase your creativity by adding your videos, your creative side, whatever in media and entertainment sector you do. You can put it on social media and tag with a hashtag Creative Me. Also, there is a virtual dancing star show going on, and the auditions are already on for this show. And there we have the super guru and the super judge, Suresh Mukund. Yes, he's a world champion in a dance competition, and he is going to judge a virtual dancing star. So register now, visit our website and register. Like, we have been bringing various webinars and sessions to you. We have Ms. Shweta Gore, a celebrity makeup artist and fashion expert, coming your way with another subsector of media and entertainment, fashion and glamour. Yes, so she is going to give us a workshop on how to do makeup for fashion shows. So be ready with your, your vanity kit, and do join the web session on Tuesday, July 28th, 4 p.m. Indian time. We also have Mr. Gagandeep Sidhu joining us on 1st of August, 4 p.m. He is a motivator, he is a speaker, he's an influencer. And during this situation of COVID, he's going to bring us a lot of positivity, because he is founder, owner of Positive Minds. So yes, do join us for the law of attraction and subconscious mind on August 1st, 4 p.m. We will keep updating our certificates. Your certificates will be available after 3 days of attending this session. So that means, if we count it, after the session of Ms. Shweta Gore, you can visit our website www.vidyadaan.net and download your certificate from there. So with this, I'll take your leave. Thank you so much for your time. Have a good weekend. Enjoy. Take care of yourself. Stay safe. And yes, keep attending our sessions. See you in the next session on Tuesday with Ms. Shweta Gore. And thank you so much, Dave and Chris, for your precious time. Thanks to AID, Asian Institute of Design. Yes. Take care. Stay safe. Bye-bye.